Hello, hi everyone. Welcome to the student brand. This is Abaswa sir. Today we are going to discuss about light reflection and refraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. When light falls on the surface, it reflects back. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so we are discussing about light reflection and refraction. So please click on like button. So if you please click on like button. So this live, can I get 1000 likes? This live class can get 1000 likes. So please, if you choose hard work, so click on like. If you choose talent, so you can click on subscribe button. If you choose like, you can click on like. If you choose talent, you can click on. So I hope it is very clear. Now we will discuss about light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Yes or no? Okay. Now you can observe here light reflection and refraction. Light reflection and refraction. Light reflection and refraction. Refraction. Light reflection and refraction. So when light incident on the surface, it reflects back. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so here I am taking the surface. Okay, plane surface. One side is reflecting surface, another side is coated, silver coating. One side is reflecting surface, another side is silver coated. So this is the incident ray, and this one is the reflected ray, and the light ray which is perpendicular to the plane surface is called normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And the undeviated line. Okay, so the light ray which is moving, so this is the undeviated line. The angle between reflected ray and undeviated line is called angle of deviation. So please do like, share and subscribe to Student Brand if you like the content, if you like the channel. So make me to reach to maximum number of students. So try to reach my goal. So let me reach my goal. So please can click on like button, then all I can. So I need 1000 likes to this class. So can this live get 1000 likes? So please think about it and do it. And the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Okay, and here, so loss of reflection. So here you can observe. So first one, incident ray, reflected ray. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incidence is equal to angle of reflection. And coming to the deviation, so this is the deviation angle, that is, so the angle between incident ray, normal angle of incidence, angle between reflected ray, normal angle of reflection, reflected ray and undeviated line is called angle of deviation. So that is everything include of angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So from laws of reflection we know that angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Understood? So that's why I'm taking angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. And so an angle of deviation equal to 180 minus 2 angle of incidence. So and also we can write angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So angle of deviation equal to 180 minus 2 angle of incidence I can write. And angle of deviation equal to 180 minus 2 angle of reflection also we can take, because so we know that angle of incidence is equal to angle of reflection. So from that we can take angle of incidence is equal to angle of reflection. Okay, so try to click on like button. So and let me reach to the maximum. And if you like the content, if you like the channel, please click on like button and click on like button so that I can understand. So its class is good. So people are listening to the classes and I can understand. So people are watching and liking the content, so that I can continue with happily. So I need, so click on like button, so share to everyone, ask your friends to join to the class, and subscribe the channel if you like the content, if you like the channel. So this is about laws of reflection. And coming to the bouncing back of the light from the reflecting surface is called reflection of light. Bouncing back of the light from the reflecting surface is called reflection of light. Okay, so so now we'll discuss about regular reflection and irregular reflection. Regular reflection is nothing but incident light rays are parallel, then reflector light rays are also parallel to each other. That type of reflection is called regular reflection. Coming to irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. That type of reflection is called irregular reflection. Understood? So 1, 2 and 3, 4. These are incident light rays. After reflection, those light rays are reflecting back into the same medium. Those are called reflector light rays. So these are the reflector light rays. Reflected light rays. Okay. So this is the incident beam. Incident beam. Incident light rays. You can say incident light rays. Incident light rays are parallel. Then reflector light rays are also parallel to each other. Reflector light rays. Reflector light rays. Okay, so incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection, so incident light rays are parallel, but reflector light rays are not parallel to each other. So I'm taking here, so this is the 1 and 2 and 3 and 4. So these light rays are moving in different direction. These light rays are moving in different direction. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Understood? So regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Next one will get it no. Example for regular reflection, plain mirror and still water surface of a lake. Coming to irregular reflection takes place on wall. So there is one question. Yeah, numericals also we are doing. Concept plus numericals. So continuously we are doing on it. Okay. So definitely we'll do numericals. Okay. So next. So that is about regular reflection and irregular reflection. Now we'll discuss about object and image. Object and image. So I'm taking here this object. So you can see this is a point. Light rays are coming from this point, and from this point after reflection, the light rays are meeting at one point. So this is the real image. And if you are extending those light rays will meet at one point. That is a virtual object. The point of intersection of reflector light rays. So the point of intersection of reflector light rays is called real image. The point of intersection of extended incident light rays is called virtual object. And coming to the next one. So here you can observe. So pole. From this point, light rays are coming after reflection. Those light rays are moving away from it. You can observe. These light rays are moving away from it. If you are extending these light rays, extended light rays are meeting. This is a real object and a virtual image. Real object and virtual image. Understood or not? And coming to here, object is real object and virtual image. Object and image. Object is real, image is virtual. Object is virtual, image is real. Understood or not? So this is the object and image. Object is real, image is virtual. Object is virtual, image is real. So here you can observe the point of intersection of reflector light rays. Reflector light rays are meeting directly, so that is called real image. Extended incident light rays. So incident light rays are extending those light rays will meet. Extended incident light rays are meeting at one point. Their virtual object is forming. And here you can observe. So the point of intersection of incident rays. These are the incident rays from this point. So this is the real object. Okay. So real object. And you can observe. So the point of intersection of extended reflector light rays. So reflector light rays are extended. Those light rays are meeting at one point. That is a virtual image. The point of intersection of reflector light rays is called real image. The point of intersection of extended reflector light rays. So extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. The point of intersection of extended incident light rays is called virtual object. And the point of intersection of incident light rays is called real object. So object is real, image is virtual, object is virtual, image is real. Understood or not? So this is very, very important. And next one. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. This object, AB is the object. So I am taking this light ray. After reflection, those light rays are moving away from it. So when light ray is passing along the normal line, if the light ray is passing along the normal line, what happens? So it retraces or reflect back into the same path. The light ray is passing along the normal line, it retraces and moves in the same direction. Okay. So here you can observe. So this is the light ray After reflection, those are moving away from it. And here also, after reflection, those light rays are moving away from it. So if you are extending these light rays, extended light rays will meet at one point. Okay, so extended light rays will meet at one point. You can observe here. So here I am taking like this also I am taking here. So here and here. So this the A dash and B dash. A dash and B dash. Understood or not? A dash and B dash. So now we can observe. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. So object, first point is object is real, image is virtual. Object is virtual, image is real. And object distance, the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. And the height of the object is equal to height of the image. And magnification is +1. Magnification of the plane mirror is +1. And also it shows lateral inversion. What is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. Okay. So next one we'll discuss about one more, that is so spherical mirror. There are two types of spherical mirrors. One is concave mirror, another one is convex mirror. So concave mirror is also concave mirror is in converging nature. Convex mirror is in diverging nature. Concave mirror is in converging nature. Convex mirror is in diverging nature. Okay, so now we will discuss about terms related to spherical mirror. So these are the terms related to spherical mirror. The center of the imaginary sphere in which mirror is a part is called center of curvature. The line joining of center of curvature and pole is called principal axis. So here you can observe the center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The distance between center of curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point on the principal axis called focus. So here you can observe these light rays. After reflection, all light rays will meet at one point on the principal axis. So this is the focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And width of the mirror is called aperture. Width of the mirror is called aperture. So these are the terms related to spherical mirror. The center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. The distance between center of curvature and pole is called radius of curvature. The line joining of center of curvature and pole is called principal axis. And so we can say, so after reflection, all light rays will meet at one point on the principal axis called focus. The distance between focus to pole is called focal length. Okay, and width of the reflecting surface is called aperture. And the next one, so we'll discuss about one more, that is ray rules. Ray rules of concave mirror and convex mirror. So there are 4 ray rules are there for concave mirror and convex mirror also. So I am taking the concave mirror. So pole, focus, center of curvature, light rays passing after reflection, it passes through focus. And coming to the second one, light rays passing through focus. So pole, focus, center of curvature, light rays. What is this mirror? Concave mirror or convex mirror? Convex mirror. So we are discussing about concave mirror. So concave mirror we will draw one side, convex mirror another side. So it is good. So I am taking the concave mirror. So pole, focus, center of curvature, light rays passing through focus after reflection moves towards infinity. And coming to the third one, light rays. So this is the pole, focus, center of curvature, light rays passing through center of curvature, it reflects back. And coming to the fourth one, pole, pole, focus, center of curvature, light ray is incident at the pole, it reflect back. Light ray is incident at the pole, it reflect back. Okay, so I hope it is very clear. So classes regularly it will take, so morning 10 o'clock, 10 a.m. and 3:30 p.m. and 6 p.m. and around 10 p.m. Okay, so first class morning at 7, morning at 10, second class 3:30, third class 6, fourth class 10. So likewise classes will go on. Likewise classes will go on. Yes, 10 to 10. So those are the timings for me. So I hope it is very clear. So throughout the day classes will go on, live classes will go on, topics will be discussing, so problems will be discussing, important topics will be discussed. Okay, so throughout the day classes will go on. So inform your friends, ask your friends to join to the class. Okay, so regularly these classes timings will be fixed. So continuously classes will go on throughout the day classes will go on. Okay, till when? Till 12. Okay, so until 12 it will be happening. So 10 it will start. So starting, these are the starting timings. So it depends on the topic, explanation, problems, it goes on. Okay, so until 12 it will be there, right from 10 onwards until 12. So you can ask your friends to join to the class, inform your friends. If you like the channel, if you like my explanation, so if the content is good, check the content, verify the content, check the videos, check all the videos, and then you can get back and share to all your friends, inform to them, then ask them to join to the class. Okay, so I'm doing a lot of hard work, so try to support the channel, try to encourage the channel, so inform to your friends, and do like. So whenever you enter into the class, click on like button, and subscribe the channel if you are new to the channel. If you already subscribed, so share those videos to your friends and check the videos, so check the content, so you can join to the live classes. Okay, so we have to do our own. Okay, so we need to do our own things, we have to do our. Okay na? So that is the aim. So I wanted to start my own. Okay, so already started, it's going on. So with your support only I can able to go forward. Please support the channel, encourage the channel, share to everyone. Okay, so do like, share and subscribe to Student the Brain. Thank you. Those are supporting, thank you so much. So now you can see concave mirror. Coming to the concave mirror. Concave mirror already completed, no? Convex mirror. Concave mirror. Convex mirror. So this is the convex mirror. So pole, focus, center of curvature, light rays coming from infinity. After reflection passes through focus. There's the first one, coming to the second one. So this is the pole, focus, center of curvature, light rays passing through focus, after reflection passes through. So light ray is coming, passing through focus, after reflection moves towards infinity. And coming to third one, light rays, so pole, focus, center of curvature, Light ray is incident at the pole, it reflect back. Coming to the fourth one. So pole, focus, center of curvature. Light ray is passing through center of curvature, it retains virginal path. So it moves in the same direction. It moves in the same direction. So I wanted to share this channel to everyone, inform to everyone, ask them to join to the class. Okay, so let them know there is a physics live class is going on based on CBSE grade 10 physics. Okay, so ask them to join to the class, inform to everyone. This is a topic, light reflection and diffraction. Okay, so for this live I need to get 1000 likes, so that is a target. That's why I'm writing. So do like, ask your friends to share the channel. So like the channel, subscribe the channel. So do help in that. Let me reach to the maximum number of students. Let me reach. Okay, done. So come to the point. So I hope it is very clear. Now, image formations. I'm taking the concave mirror. Concave mirror, pole, focus, center of curvature. Light rays coming from infinity after reflection passes through focus. Okay, object is at infinity, image is forming at focus. Nature of the image is real and inverted, size of the image is highly diminished. So first one. Okay, object is placed at infinity, image is formed at focus, nature of the image is real and inverted, and size of the image is highly diminished. And coming to the second one, so here you can observe this the pole, focus, center of curvature, pole, focus and center of curvature. So object is placed beyond center of curvature. One light ray I am taking, it passes through focus. Another light ray is passing through center of curvature. So the light rays will meet between C and F. Object is placed beyond C. Image will form between C and F. Nature of the image is real and inverted and diminished. So image size is decreased. Compared to the object, image size is decreased. Okay. So that is the next one. Yeah, yes, that's why. So need to work out on my own. That's why I'm working on. So next one you can see. So pole, focus, center of curvature. Object is placed at C. Image also will form at C. One light ray I am taking. So another light ray is passing through. So one light ray I am taking. So here you can observe. Object at C. Image also will form at C. Nature of the image is real and inverted. So image will form at C. Object at C, image also will form C. Nature of the image is real and inverted. Size of the image is same size. And coming to the fourth one, object is placed between C and F. Yes, correct. Object is placed. So this is the pole, focus, center of curvature. Object is placed between C and F. One light I am taking like this. Another light ray incidenting at the pole. Those light rays will meet here. So the image will form. Here. Object is placed between C and F. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. Understood? So next one, fifth one. So here you can see concave mirror. So pole, focus, center of curvature, object is placed at F. One light ray I am taking, it passes through focus. Another light ray is incident at the pole, it reflects back. Object is placed at F, image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Because point size image is formed at infinity. Okay, highly enlarged. Understood? So next one. So sixth one. So pole, focus, center of curvature, object is placed between F and P. One light ray I am taking, it passes through focus. Another light ray incident the pole, it reflects back. So if you are extending those light rays will meet behind. Okay. Object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. So compared to the object, image size is increased. Understood or not? Object is placed between F and P. Image will form behind the mirror. Nature of the image is virtual, erect and enlarged. So these are the points. So object is placed at infinity. Image will form at focus. Nature of the image is real and inverted. Size of the image is highly diminished. And coming to here, object is placed between beyond C. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. Object is placed at C. Image also will form at C. Nature of the image is real and inverted. Size of the image is same size. And here object is placed between C and F. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged. And here coming to the this position, object is placed at F. Image will form at infinite. Nature of the image is real and inverted. Size of the image is highly enlarged. And here object is placed between P and F. So P and F, image will form behind the mirror. Nature of the image is virtual, erect and enlarged. Okay, so these are the So in convex mirror only two cases are there. So those are object is placed at infinity, image will form at focus, nature of the image is real and inverted, and size of the image is highly diminished. And the next one, object is placed between P and infinity, image will form between P and F, nature of the image is real and inverted. Nature of the image real and inverted, virtual erect. So object is placed at infinity in convex mirror. Image will form at focus. What is the nature of the image? Virtual, erect and highly diminished. And coming to the next one, object is placed between P and infinity. So nature of the image is virtual, erect. Image will form between P and F. Okay, so those are the convex mirror. Convex mirror image formations. Okay. So here now I explain concave mirror image formations. Alright. So sign conventions. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So those are the points. All measurements will be taken from the pole in the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis positive, below the principal axis negative. So those are the sign conventions. Understood? So now we will discuss about numericals. Okay, let's wait. So let's start. Wait some time. Let's start solving numericals. So I'll write one question, try to solve it. So very important question. Try to solve it. So real 4 times larger than the object. Larger than object. Object. So calculate the distance the distance the distance of the image from the mirror. So try to solve this question. So try to identify the question from the mirror. So try to identify the question and try to solve. If you didn't get, no problem, I'll explain, don't worry about it. So I'm here to explain. So time 4 minutes. Okay, 4 minutes time. Do like, share and subscribe. So like, share and subscribe the channel. So do like, share, and subscribe to Stan. So here you can see the answer is actually the magnification is -4. Magnification is -4. Understood? So m equal to -4. M equal to -4. That is, so an object is kept. So object distance is -12 centimeter. In concave mirror, it forms a real image of 4 times. Real image 4 times they mentioned. Okay, real image 4 times means m equal to -4. M equal to -4. So a large image. So larger than the calculate the distance of the image from the mirror. So now you can see -4 equal to -v by u. Okay, so substitute the value. Now -4 equal to -v by -12. So this will get cancelled. So v equal to -4 into 12. How much? V equal to -48. Understood or not? So v equal to 12 centimeter. So v equal to -48 centimeter. That's the answer. So they are asking calculate the image from the mirror. Understood? I hope it is very clear. So image -48 centimeter. If it is correct, if my explanation is good, just you can click on like button and subscribe the channel. And going to the next one. So if you want to draw the diagram, you should find out the focal length. So they asked to find out only image. So you can find out the focal length. So find the focal length, by that we can draw the ray diagram. So real image means object is placed between C and F. If object distance is 12, then automatically image distance less than. Okay, so then we can draw the. So which case object is placed between C and F. C and F. So that image we can draw. Okay. So that is this case. So definitely real and inverted image form. No? So here you can observe this the pole. This the pole, focus and center of curvature. So object distance, so more than focal length, then only the image will form here. So that too they mentioned concave mirror. In concave mirror only. Actually it is for CBSE grade 10. So CBSE grade 10 physics. So it will be helpful for 12th also. Those who are attempting JEE, NEET, 12th. So ray optics. So ray optics is there, no? It will be helpful for that also. So you can attend the classes, fine. And electricity, I'll start 12th electricity. Okay. So already explained the topic. I will explain once again. Okay, done. Come to the point. So in this case, if you place the object here, one light ray I am taking like this, it passes through like and another light ray. So we can take extension. So we can take extension like this here. And okay, so like this you can take. So you have to identify. So if you want to draw the ray diagram, compulsory you should know focal length, object distance. So by that we can get to know where image will form. So we know the image formations, right? That too concave mirror they mentioned, so you can draw that one. So if you like the content, if you like the channel, do like, share and subscribe to Student the Brand. Okay, done. One more question. One more question. Shall we do refractive index? So actually, lenses we didn't do, I hope. These are definitions. Regular reflection and irregular reflection. This is about lenses. Lenses, image formations. So can anyone say the answer? What is the value of? What is the value? What is the value of n21 into n21? What is the value? Anyone knows the answer? Wow, that type of questions. Sometimes they'll ask to draw the ray diagram. So theory they will give. They'll ask to draw the ray diagram. Those type of questions they will ask. So that by giving data, so they will give like previous one. They will give the data based on that one. Find the unknown quantity. Then you can draw the ray diagrams like this. They will ask. So there are questions are there. So I came to refraction, lenses. Okay, fine. So we'll see. Anyway, next class or coming class we'll work out on remaining problems. So based on refractive index, problems are there. We'll do based on refractive index. Okay. So you can. So anyone knows the answer to this question? What is the value of? What is the value? What is the value of n1 to n21? Answer to the question. No knows. So until few members, at least 1 or 2 members answer, I'll start. Okay, fine. Actually, I made so many concept explanation videos and problems also. So I hope Johan, I made so many videos related to light chapter, especially CBSE Grade-10. Okay, so you can check once. You can watch my previous videos. Okay, so definitely you'll get the concept. Still now also I explained the topic only just before. Once you go back and check, so until I explain image formation by concave mirror. Okay, until that I did the diagrams. So just check once. Otherwise you can watch my videos. So you can check, there are many videos are there related light reflection diffraction chapters. So many times I explain. One check. And problems also practice is there. So anyway we'll do problems practice like this. So practice session also will go on. And along with the explanation. After explanation so we'll go with the practice. And like remaining chapters, human and color fluid, electricity, magnetic effects of electric current. Like that all the chapters. So vigorously we are working on it. So continuously I'm explaining the chapters. Once check the chapters. So it's a textbook call it. Textbook related diagrams only. So I'm not going to anywhere. So cases, conditions, concepts. So completely from textbook itself. CBSE textbook. Okay. So you can check those videos. Then you can inform to your friends, ask your friends to join to the classes. Share this channel to everyone, your friends, ask them to watch. So definitely they will like it. Okay, so anyone answer to this question? Anyone answer to this question? So answer is 1. So you can check. N2 by N1 and N1 by N2. So will get cancelled. So answer is 1. Subscribe. Thank you so much. We'll see you in the next class with a different topic. So like, share and subscribe to Student the Brand. So that is a refractive index. That's a lengthy concept. It will take time. So join to the classes. So follow regularly. 6 o'clock class is there today. So and 9 o'clock, 10 o'clock, 6 o'clock class is there today, and 9 o'clock also. So related to this one concept is there. So I'll explain refractive index if it is possible. Otherwise I'll go for magnetic effects of electric current. Actually magnetic effects of electric current I need to explain. Okay, so once you go and watch the videos, so I'll explain this refractive index, right? Yes. Thank you. We'll see you in the next class.